Alright guys, we're going to use Newton's second law to solve some problems. So I'm just going to do number 1 and 2 with you on this sheet, so follow along. Number 1, I changed some words in it. Just look at what I crossed out here, because it doesn't really change the problem too much. It says a 0.43 kilogram, so that is the mass, is 0.43 kilograms. Soccer ball is kicked horizontally, left to right, with a force of 20 newtons. So remember, we have two forces. We have FP and FF, alright? Which one is the kick? Is it a push or is it friction? It's more like a push, right? So 20 newtons is the force of push on the ball, while the frictional force of 2 newtons acts on the ball. So FF is going to be 2 newtons, alright? And letter A, they want us to calculate the acceleration of the ball. So A equals question mark. First thing you do before you plug in, always draw a force diagram. FP to the right, FF to the left, and label the forces if you know what they are. 20 newtons and 2 newtons. And that'll help you remember in your equation, Newton's second law is F net equals ma, and we're going to use that to calculate our acceleration. Now the net force is the sum of these two forces combined, Fp and Ff. Remember, Ff is to the left, so it is a negative. So we could always, if we want to, we should want to, write Newton's second law like this. Fp minus Ff equals ma. And then we could plug numbers in from our list. Your list is always going to have 4 components with Newton's second law. Fp, Ff, m, and a. Alright? Now, we could plug in our numbers. Fp is 20, Ff is 2, m is 0.43, and then we have a, which we're going to solve for. So our first math move, I see a 20 minus 2 over here. That would be easy enough to make it into 18. And then I'll rewrite 0.43 times a on the other side of the equal sign. Now, to get a all by itself, I'll divide both sides by 0.43, the mass. And a will be equal to 18 over 0.43. Can you take out your calculator? You can pause it if you'd like to. And I'm going to do 18 over 0.43 on my calculator too. So A, I got to be 41.86, and the unit for acceleration, just like gravity's unit, is m over s squared. Alright, big acceleration because it was a hard kick. Alright, now let's do number 2. Using the same process. So number 2, before I even read it, I'm going to make my list. M, Fp, Ff, and A, the 4 components of Newton's second law. Alright, now we can read it and put the numbers in the list, okay? It says a soccer ball of mass 0.43 kilograms is dribbled along the ground with a foot pushing it with a force of 2 newtons. So the foot is pushing the ball, so that's the force of push, is 2 newtons. And they're pushing it at a constant velocity. Letter A says calculate the frictional force on the ball. So we're looking for, instead of A this time, or question mark, it's going to be FF out of that list. Alright, so it looks like I only have 2 numbers, so I'm looking for a third. I kind of need to know what the acceleration is, you know, in order to do this problem, or else I can't get an answer for FF. That is an issue. But look at this word, constant velocity. So that is a meaning for acceleration. When you're moving at a constant velocity, you're not speeding up and you're not slowing down. speeding up is a positive acceleration, slowing down is a negative acceleration. So if you're not speeding up or slowing down, you don't have a positive acceleration, you don't have a negative acceleration, you have an acceleration of 0. So write that next to constant velocity and underline it on your problem set. Where you see the word constant velocity, write a equals 0. All right, and we can write that in our list over there. I'm going to write an arrow pointing to that saying that's because you're moving at a constant velocity. That's why a equals 0. All right, so then we can finish our problem by doing what we always do. Draw our diagram, then use the equation. The diagram I'm going to require for all your problems with FP on it. And if you know the number, put it. With FF, we don't know the number, so we'll just write FF equals question mark. Just draw the box with the 2 arrows, and then you can start your equation. FNet equals MA, and that's always going to break down into FP minus FF equals MA. And I'll ask you for one of those 4 variables, FP, FF, M, or A. All right? So this time I'm asking you for FF. We could plug in the FP from our list is 2 minus FF equals M is 0.43, and A, oh, they didn't tell us what A was, but we knew because it said constant velocity that A is 0. So what you're going to notice is that when A is 0, on the right side, 0.43, whatever the mass is, this time it's 0.43 times 0, is just 0. All right, so it's going to make things a lot easier. On the left side, we'll rewrite it, 2 minus FF, but equals 0 on the right side. So what do we do from here? Well, we can move something over to the right side, okay? And it looks like we could basically add FF to both sides. It's like adding X to both sides, sort of like that, you know? And on the left side, it's going to cancel, and it'll show up on the right side. And what's left over on the left side is just the number 2. All right. So, FF equals 2, and that's it. It looks like when everything is equal and it's good now, all right? So what you're going to notice is that when objects move at a constant velocity, the forces, that is FP and FF, are balanced, or in other words, they're equal. And we learned that before, guys, when we did, we learned that before when we looked at terminal velocity, when the air resistance was equal to the gravity and it continued at a constant velocity, all right? And the forces were equal, all right? So if you don't want to do all the math, if you notice the word constant velocity, just know that these 2 forces are going to be the same number. If you see the word constant velocity, that'll work out good for you every time. All right?